Hi, this is Bob from INSYDIUM, and in this NeXus tutorial we'll have a look at using nxPush and xParticles to create some stunning sims. First we'll get these particles to interact with each other using an nxPush. Then we'll add some dynamic movement using an nxScale and fields. Then, because this is so fast on the GPU, we're able to add thousands more particles and play it in real time and add more animation effects. And then we'll look at adjusting this stylized scene to make a more realistic sand animation, again playing in real time, and this is what we used to create our sand render. So let's jump into Cinema 4D and get started. So let's set up our nxPush scene. First of all, we'll bring in our xParticles system. So let's go to the INSYDIUM menu, to xParticles, and bring in an XP system. This is our organizational hierarchy where we can organize all of our various different xParticles objects. By default, an XP emitter is brought into the scene, and we can see this square emitter in our viewport. If we hit play, you'll see that that starts emitting, and if we move the camera, it's firing out these particles in the +Z direction. Okay, that's pretty good. Now at this point, it is important to say that this emitter is working via the CPU. Now the reason I know that is that it is this blue color. Now when we start getting emitters working on the GPU, the color will turn orange. Now this is an entirely automatic process to change an emitter from a CPU calculating particles to GPU calculating particles. It all happens under the hood for you automatically. There aren't any buttons that you need to check to activate GPU, and we'll demonstrate that when we start bringing in our NeXus modifiers. Before we do that, we need to bring in our spline from which we will be emitting particles, because we don't want to use this square. So if we go to our splines menu, let's bring in a flower. And if we just move the camera back, we've got this pretty big flower. Let's reduce that inner radius way down to, say, I don't know, 10, and the outer radius way down to, let's say, 40. All right, that's kind of within our emitter. And obviously that inner radius is too small, so let's put that up to, say, 15. Yep, that's looking good. Now, I don't want as many petals on this flower, so let's reduce that to a nice odd number. We'll put that on 5. Always prefer odd numbers in such objects. All right, that's looking good. We're going to emit from this flower shape. So to get that to work, we need to go to the emitter and change the settings. Let's go to the XP emitter. We'll go to the Object tab, and by default, the emitter shape is set to this rectangle that we can see. But we don't want that. We want to emit from an object in the Object Manager. So let's pull this down and select Object. And then here it's asking which object do you want to emit from. We need to drop it in this link field here. So let's bring the flower and drop it in there. Now at the moment it's saying emit from, the default is polygon center. Well, this isn't a polygon object, it has no polygon, so that won't work. So we need to pull this down and let's select edges, and that is going to work. So now if we hit play, we're going to get particles flying off from the edges of this spline. Let's just remove that particle speed. We don't need them to be moving. So let's go to the emission tab, and in our basic particle data, we'll take off this default speed and we'll put it down to 0. Hit play, and we're now getting particles emitting around the edges of that spline. Let's just make the spline invisible, and then we're just seeing the particles. So if we go back to the first frame, no particles, and then over time the particles are being born around that spline. Now you can see that we haven't got an even distribution of particles here. Look, these straight parts of the spline have very few particles, and the curved parts have loads more particles. And that's because it's based on the interpolation of our flower and how our intermediate points are being generated. And adaptive means that the intermediate points are based on the angles of these curves. So if we want this to be even, we can just change it from adaptive to, say, let's have a uniform distribution. Let's see if this gives us smooth enough curves. We'll hit play. Yep, that's looking pretty good. There's arguably not quite enough adaptive points here. It's a little bit of a jagged curve, so we could put that up to, say, 12 points. Play again, and then we're going to have a smoother curve. So that's going to do us. That's looking good, and we've got these particles. Now, we don't want all the particles to be born at the same time. We want them to born as if the emitter's kind of flying around the perimeter of this flower. And we can achieve that really easily if we go to our XP emitter, to the Object tab. At the moment, the emission point is set to random, so the particles are randomly emitting from anywhere on that spline. But if we change that from random to set, we can set at which point along the spline the particles are being emitted. By default, it's set to 0 position, so right at the start of the spline. So if I hit play, you're just going to see one dot, but there's loads of particles being born on top of each other in that exact same position. If we animate this position, we're going to get the effect that we want. So let's go back to the first frame, add a keyframe here. Let's go forward to frame 90, let's say, and we'll add a keyframe at 100%, so it's made its way all the way around the flower. And now if we hit play, yes, look, we're getting an emission of particles going all of the way round. Now, we have got more particles here because we have an ease in and an ease out of this position change, and that's just the default interpolation of those keyframes is set to have Bezier handles, and we don't want that. We want this to be kind of effectively looking like it's the same speed. So we need to adjust those keyframes. To do that, let's just hit this little keyframe symbol here. This opens up our timeline with our dope sheet. Let's get our emitter, drag it into the dope sheet, and if we pull this down, we can see, look, there are our position keyframes from the Object tab, and we can see them highlighted here and here. If we go up from the dope sheet to the F-curve mode, it's just a different type of graph showing the same thing. So let's click on that, and you're going to see, look, there's the same keyframes, one there and one there, and here is the interpolation between the two, and it has these Bezier handles, which is giving us a curve in and out, and that's what we don't want. That's what's giving us this clumping here. So if we just change these keyframes to linear, now it's the linear interpolation, so it's completely even throughout the entire animation. If we hit play, we're going to have perfect distribution of those particles. There we go. And by the time we get to frame, we can shut this down now. Let's press this little keyframe button. It hides that timeline. So this is actually still emitting now. If we hit play, it's still emitting particles, but the position's just set on 100%. We can have it stop emitting particles as soon as it gets to the end, really. So let's go to our XP emitter, to the emission tab, and instead of emit all frames being active, which will just spit out particles for the entire scene, we'll deselect that and we'll put end frame. Let's just put, I don't know, an end frame of, say, 95. So now we have particles being emitted, working their way around. We get to frame 95 and there's no more emitted particles. Excellent. So that is all set up. Now we can start looking at making some changes and then bring in our dynamic NeXus simulation. So let's go to our display tab. And instead of showing, if we go down to our editor display, instead of showing the squares, which is the default, let's show something that will actually show the size of the particles, because the squares are the same size whether the particles are huge or tiny. So let's go to particle type circle, resim, and now we're getting these overlapping circular particles. But it doesn't look like we've got very many, but actually there are thousands of particles in this scene. We're emitting 1,000 per second, but they're just all on top of each other because of the way in which our position is animating along that spline. So we can view and kind of offset the position of those particles so we can see lots more. Let's go back to the Object tab, and we want to change this. So we've animated our position, but we want to change the spread. At the moment it's 0%, so they're all just emitting on top of each other as they animate round that spline. But if we increase this to, say, 3% and hit play, now we're going to see, look at that, with offsetting the position of the same amount of particles, and now we can see loads more, and it's really kind of filled out that spline. So now that we've done that, Let's just reduce the size of these a little bit, and it'll make it easier to see the effect of our first NX modifier that we're going to use. So let's go to the emission tab, and in the radius, let's put this down to, let's try just 1 centimeter radius. Okay, so there are our particles, all being born and intersecting. So a reminder that our logo for our XP emitter is blue. This is only working on the CPU at the moment, but now we're going to bring in our NeXus modifier for this sim. So we go to our NeXus menu, we'll go to the objects, and we want the nxPush modifier. And as soon as I bring this in, watch what happens to the color of our XP emitter icon. So we'll go to the nxPush, bring it in, and look, it's gone orange. So because we have brought an NX modifier into our scene, the emitter has automatically been switched to GPU mode, and it's done for you. There's no GPU button required. So what the nxPush does is it iterates through every single particle, and it tries to push them apart dependent on our distance. So let's go to the nxPush. And the distance mode by default is set to absolute, and the distance is set to 10 centimeters by default. So it's going to try and push every particle so they're all 10 centimeters apart. So if we hit play, it's pushing them all apart, look, and it's going to carry on pushing until they're all 10 centimeters apart. And if we come right out, look how far it's spread those particles out, trying to get them to be 10 centimeters apart. Now, on the scale of our scene, 10 centimeters is quite a lot. So we could either reduce that, or let's just use the other mode, which is, I think, the really exciting mode. If we change this from absolute to particle radius, now it pushes them apart, the particle radius. And the result is that we get this amazing circle packing effect. Over time, it's pushing these until there is no intersection of these particles. So that is pretty cool. And the beauty of using particle radius is, if we've got particles of different sizes, it still works. So let's have a look at that. Let's go to the XP emitter, to the emission tab, and let's reduce the radius to 0.5, but let's give them a variation of 0.5. So this is saying that any one particle will be born with a radius of anything from between 0.5, 0, and 1, because it's 0.5 with 0.5 at either side. So anywhere between 0 radius and 1. So let's have a look at how that changes our sim. So now we've got these varying different particle radii, and look, they're being pushed apart automatically, so they're perfectly packed, and we're getting this amazing result. It looks like bubbles, doesn't it? And it's looking really nice, and this is all simulating on the GPU, and this is an incredibly computationally heavy operation here. So this type of sim using the nxPush really is where using the GPU shines, because this is so much faster than using the CPU version of this modifier, and we'll do a comparison of that a little later. But there we have got our really nice sim, and that's looking pretty cool. Now you can see that it's pushing them apart at kind of a particular rate. If we just dolly in, you can see it's pushing them apart until it's solved it. And this bit's a bit more tricky because there's loads intersecting, but eventually it gets there. If we go to our nxPush, we can actually get that to speed up. First of all, we can get that to speed up by just increasing the strength of that modifier. Let's put that up to 100%, and we'll see that it pushes them more quickly, and it'll get to that solved point more quickly. But we're also able to increase the iterations, and these are the simulation iterations. This is how many times per frame it iterates through every particle to work out how much it needs to kind of push them apart to get that particle radius distance between them. So if we increase the iterations up to, say, 20, it's going to be, again, this is computation heavy, but look how quickly it pushes them apart. It's almost becoming instantaneous, so it becomes a much more accurate sim by increasing the iterations. We'll just put that back down to the default 5 for now. So that's looking pretty cool. We've set up our emitter, we've brought in an nxPush. Because it's an NX modifier, it's automatically converted our XP emitter from CPU to GPU, and we've got this pretty interesting animation set up. So now we can start looking at how we can make some adjustments to this to make it look a bit more interesting. So first of all, what we can do, if we hit play, you can see that we've got all of these nice particles, but they're all the same colour, of course, and it would look much more interesting if we could colour these maybe via their radius. So let's have a look at that first before we look at creating some nice organic motion in this. So we'll go to our emitter, let's go to the display tab, and we'll just move this up a bit. By default, you can see we've got our editor display set to circle, but our particles are all the same color because this is set to single color mode. So let's change that to gradient parameter. And now we're able to map this gradient to the particle's parameters. So for example, this is set to, by default, gradient parameter age. So it's saying that when particles are born, they are blue, and as they get older, they gradually go through this blue to white at the end of the scene. So if we hit play, you'll see that they're all born a blue colour and they gradually turn white. So that's all well and good. It's not what we want. Let's say we'll colour them via their size. So to do that, let's change the gradient parameter age to radius, and we can put a minimum and a maximum radius in here. So let's just find out what our min and max are. We'll go to the emission tab. And yeah, so our max radius is 1 centimeter. So let's go back to the display and we'll put the max of 1. So this is saying that particles that have no radius, that are 0 centimeters, are blue, and particles with 1 centimeter or above are white. And if we hit play, you'll see that there we've got our difference. Okay. So that's looking pretty nice. It's not really the kind of colour scheme that we want. I was going to go for more of a nebula type look with some nice purples. So what we'll do is, instead of using the default gradient, let's go to our load preset. And there's actually, look, this Flame 6, this is one of the default Cinema 4D presets. Let's use this and adapt it. So we'll double click on that, which brings it into our scene. And we want to get rid of, actually we can maybe keep this dark one. Let's get rid of this one, this one, this one, and this one. And then let's just use it as that for now and see what we get. So that's looking way more interesting. Okay, so we'll leave it at that for now. We can always make some adjustments. So now we have this nice animation of our emission of particles, and then the push is pushing them apart based on the particle radius. But we could get some really nice organic motion in here if we could animate almost randomly the size of these particles so they grow and shrink and grow and shrink, and then that will have a knock-on effect on the nxPush operation. So let's get that set up. We'll just make a bit more room here in our object manager, and we'll go to our NeXus menu, and we want to bring in a modifier which is going to affect the size of the particles. So let's bring in an nxScale. We can do that. Now by default this is set to change value over time, 0.2 centimeters per second. So these are going to grow really fast now and just keep growing and growing and growing. So let's have a look. Yep, they're being emitted, they're growing, and look, they're all turning black because they're all getting to be larger than 1 centimeter very quickly. So let's change that. Let's just put this a much lower amount. Let's put like maybe 0.005. And now they're born, and then they're gradually getting bigger. Look, you can see they're gradually getting bigger and turning black as they meet that 1 centimeter radius threshold. But the push is still it's still calculating every frame and pushing them apart. Even as they grow, it's still trying to push and push and push. And if we need this to be more accurate and to try and separate these more quickly, we can go back to the nxPush. Remember, we can increase the iterations. Let's put this up to, say, 30 iterations. And now it's going to be able to better keep them apart. Look, there's far less intersecting, even as they start growing, and it's pushing them out more. So that's working pretty nicely. Let's just put those iterations back down to the default 5 for now, because we don't want this actually. We don't want these particles to be getting bigger and bigger all the time. We want them to grow and shrink and grow and shrink in an organic way. That's going to get some nice motion. So to do that, let's go to our nxScale and change the operation from change value over time, and instead, now with NX modifiers, we don't have data mapping and we don't have questions and actions, but we do have the ability to use fields. So that's what we're going to do here. So to use a field with this modifier, we need to set the radius by a fall off. So let's do that. Then we need to bring a fall off into the scene. The fall off is going to be a field. So we'll go to our Fields tab. And what we want to do is we want to use a noise shader. We want to use the black and white, the random black and white values of a noise shader to drive the growth and shrinking of our particles. So let's bring in a noise shader from our list. Here it is, look, shader field. And this shader field lets us load in that noise shader. So if we go down to the shader part, it says what shader do you want to use? So we'll pull this down and let's bring in a noise. And then we want to edit the properties of this noise. Let's click on the thumbnail. And by default, we have this noise. Now what it's going to do, this field, is where the noise is black, the particles will have no radius, and where it is white, they will have full radius. So let's just change this noise type from noise to something like, oh, I don't know, let's try wavy turbulence. All right, so let's go back to our nxScale. So let's just leave it at that on defaults for now, and let's see the difference it makes to our scene. So we'll hit play, and what we're getting is this variation of particle radius. Now, so we can see just what the nxScale is doing with our shader field, let's remove any radius variation that we were getting from the emitter. So we'll go to the emitter, to the emission tab, and let's just remove this variation amount here. We'll take that off 0. Let's put them so they all have a radius of 1. But then the nxScale and shader field are going to come into play. And now the field is giving us these different radius values. Now what we can do to make the larger ones larger and the smaller ones smaller is to adjust that shader. Because at the moment, there's lots of mid-grays. So let's go to our shader field, into our noise. You can see that we don't really have many blacks and we don't have many whites, which will give us the full, the minimum and the maximum radius values. It's all very kind of mid-grey like. So let's go and go to our low clip, just increase this to add some more blacks. And then let's reduce that high clip to lighten it up, add more whites. And now we have this. So this should give us slightly more kind of contrasting radius values. Yep, we've got more difference there. So that's looking good. And remember, the emitter's not giving us any difference in radius. This has all been driven by our nxScale with this shader field. Now we can animate this in our noise. Look, we have an animate speed. So if we put this on, I don't know, just put it on 1. And we can see a representation of that animation in this thumbnail. If we right click it, we can click animate, and then we can see that animation. So that's how it's going to be cycling through. Let's switch that off. So then let's hit play to see the effect of that in our scene. And look, we can see those radius amounts animating with our field. And as they animate, it means that the push has to then work to push these particles apart. So that is giving us this nice kind of organic rippling, which is a pretty interesting look. Let's go back to our emitter and we will re-add some variation. So let's put this on, say, 0.5 variation. So that's looking, we're getting some really nice kind of movement now in our particles, and that's kind of pushing these apart. So that's working really well. So you can imagine even with this amount of particles, you can get some pretty nice effects just with these two modifiers. But we're going to go one step further, and we're going to massively increase this particle count, which is going to give us a really nice kind of 2D nebula effect. So let's get that set up now. So first of all, what we'll do is massively increase our particle count. So let's put this up. Look, we're on 1,000 particles per second. Let's put this up to, say, 35,000 particles per second. Hit play. So now we're getting loads more, and now we have so many particles. There's a couple of things here. First of all, this display type is not working as well for us. I mean, you may like this look, but because we have so many particles, we want a much smaller display type. In fact, we're going to use a display type that doesn't show the particle radius at all, that every particle is just displayed as the same size. So to do that, let's go to our display tab, and we're going to change our editor display from circles to dots. Now hit play, and there we go. Look, straight away, what an interesting look that is. That's looking excellent. Now also, because we have so many more particles in our sim, we don't need these particles to be quite as big. There's a lot of pushing going on here because obviously we've got lots of particles all kind of being spawned on top of each other. So let's reduce this size way down. Let's try, look, maybe a radius of 0.5 with a variation of 0.4. Let's just try that, see what we get. Yeah, so look, it's holding its spline shape a bit better. This is looking really interesting. Let's just adjust our color now, because remember, we've got it mapped to that particle radius, and we've adjusted that radius, so we're not getting the darker tones from our gradient. So let's go to our display, and we'll just move down here. And so look, we're saying that the max radius is 1. Well, they never reach that. Let's put this down to say 0.7. We'll resim. Yeah, we're getting some nice darker ones. We could even go lower than that. Let's try 0.6. Yeah, that's looking cool. All right, so this is a really interesting effect. And obviously the same thing is happening. These particles are being pushed apart by their radius. But because we've got so many particles, we're getting this fantastic look. So let's have a look at how we may animate this more. Because at the moment, we're getting this nice animation from our animated shader field. Look, we can see this animating away here. And that's because if we go back to our scale shader field, and we click in here, you can see that we have our animation speed active, which means this is animating. First of all, let's try a different noise type. Let's try, instead of wavy turbulence, let's try electric. Now electric, this is going to be an interesting one. What we're going to get with electric is, you'll see, we'll get this what almost looks like pulsing outwards of our particles, which is looking pretty interesting, almost like these circles pushing out. This is just the way it animates through its noise pattern. So that's looking nice as well. But we can get some more animation from our noise with another setting. We're able to actually animate its movement on all of the axes. We can animate this up on the Y, across on the X, or back and forth on the Z. So let's try that. So we need to move down in our noise settings, and we're going to get to this movement, and we want to move this on the Y. So we've got X, Y, Z. So we're only going to need a very small amount here because we are working at quite a small scale. So let's do it on, say, 0.5 centimeters, and then you need to put a speed, how quickly you want it to move. So let's just put this on, say, I don't know, 0.5%. This could be a bit quick. Let's have a look. Hit play. Now look, can you see this moving downwards? The noise is moving down. So that's interesting. Now, it's moving down. We're going to get a better look if it's moving up, I think. It's going to feel a bit flame-like, and it's moving too quickly. So let's put minus 0.5, so it goes up, and then let's put this speed way down to 0.15 maybe. Let's have a look. Yep, so look, now we're getting this moving up, and then all this is doing, remember, it's changing the scale of our particles, which is influencing how they are then being pushed apart by the nxPush modifier. But there we've got a really interesting look there. That's looking very cool indeed. I like that. Okay, so what else might we want to do here? Well, we could try getting these particles to fade out over time. So at the moment, they draw our spline shape. This obviously could be any spline shape. Let's say at this point, we want them to start disappearing. So let's go to our XP emitter. we'll go to the emission tab. And at the moment, they have a full lifespan. These particles are just alive for however long our scene is. So let's try taking that off and giving them a lifespan of, say, well, 90 frames will do us, because remember, it takes 90 frames for our emission point to go all the way around our spline. So we'll say particles can live for 90 frames, but if we do that, they're all going to start dying in too uniform a way. That looks quite interesting, but obviously we need to break that up a bit. So we can do that by adding some variation. If we add just a little bit of variation, we'll still get that that kill point kind of animating along the shape of the spline. So that looks quite interesting. Or if we put a really long variation on it, let's say 50 frames variation, now it's going to be a much more kind of blended out kill, where we're going to get them just kind of disappearing and floating off. So it depends on what look you're going for. Let's put this a middle ground maybe down at 30 frames. So that's looking good. So we can get them to disappear, and obviously if you want them to hang around for longer, we could. Let's just say 130, but then let's ramp up the variation. And let's get a bit more movement in here. So we've used one modifier to affect our nxPush, which is the scale. But if we change the position of these particles, obviously that's going to influence the push simulation as well. So let's add some extra movement in here by using another modifier. So we're going to go to our NX menu. Let's go and let's bring in an NX turbulence. So if we just leave this in its default, this is going to be quite strong, and you're going to see that our particles, look, they're being moved around by that turbulence and they're getting broken apart, and we've lost all shape completely. So a couple of things. It's way too strong. So let's just put this power down to, say, 0.5, and it's way too big. The scale's too big. So we can see it moving. So that's interesting, but we're losing our push apart look. Why is that? Well, if we switch off our turbulence and hit play, you can see that because our spline is working two-dimensionally, so's our push. And look, we have no depth to this simulation. It's just working in 2D effectively on two axes. But as soon as we start bringing in the turbulence, which affects particles on all axes, it is forcing them outwards in a 3D way, and that means that we're losing that interesting push look. So what we need to do is say to the turbulence, don't affect the particles on the Z, which is this way. We want them to stay as on like a 2D plane. And we can do that. We can restrict that turbulence. Look, in our turbulence settings, axis direction scale, and we have X, Y, Z. So if we put the Z on 0, the turbulence is no longer affecting those particles on that Z. Look, they're staying completely flat. And as a result, we're getting something that's looking more interesting because the push is still able to work in 2D space, and we're getting this nice movement. Now, obviously, it's not quite right yet. So let's have a look what we might be able to do here. First of all, let's change this turbulence from the default simplex, which is just like a basic noise, to something like a turbulence. And now we're getting something a little bit more interesting. Let's reduce the scale down, so it's a much smaller noise. Now, an interesting trick, a useful trick to kind of try and visualize what a noise is doing is, let's look at this noise in isolation. So look, let's take off our scale modifier and hit play. And we could also switch off our push. Let's just emit these particles, and there, look, that's what the turbulence is giving us, this type of noise. So we can adjust it in this mode, and it gives us a really good idea of exactly just isolating what that turbulence is doing. So that's pretty cool. Now, what we're able to do with our turbulence is that we can increase octaves, which basically makes the noise more detailed. So let's put the octaves up. And this is going to make a look how much difference that's made. It's kind of really almost made it very diffuse. It's so much detail. It's almost the same effect as scaling that noise down. But what we're able to do is we're able to lessen the effects of these octaves, like fade them out with this persistence slider. So at the moment, all octaves have got the same amount of power, which means that it's almost become like a tiny noise, and we've lost those nice swirls. So let's reduce the persistence. And now the subsequent octaves don't have as much power, and we're going to retain some of that nice swirling. You see, now we've got that swirling. Now the swirling could be bigger. So let's increase the global scale to get some nice big swirls, but then we're getting some detail from those octaves. Now again, I'd arguably say this is still too strong. So let's put it down to say 0.1. So there, and that's becoming more interesting now. And another thing that we're able to do is, of course, we can use fields. So we can isolate this, and we could use the same shader field that we're using to drive the scaling of our particles. So let's try that. Look, we just need to go to the Turbulence Fields tab. Let's drag in that shader field. Let's hit play. And now that turbulence is going to be isolated to parts of that field. And now that we've done that, we could perhaps, because it's effectively damped it down a bit, we could go back to the strength and put a bit more strength on now, because it's not globally affecting these particles. It's dependent on that field. That's a little bit too much. Let's put it back down to 0.5. So you can obviously play around with this until you get a look that you like, but that's looking pretty nice to me. So let's activate our other stuff. So we'll switch back on our push and our scale. Let's hit play, and our overall effect is something like this, and then that turbulence is starting to push them around, and then they start to disappear. And then they go and they kind of like wisp away to nothing. So we've got layered up lots of really interesting effects there to create this kind of nebula look, and obviously you've got all of the experimenting possible to get the exact look that you want. But for this is looking really nice. And if we kind of dolly in a bit closer, you can really see that this is an interesting effect. By having these particles of different radius values but displaying them as the same size, we're getting these really nice organic swirling and movement of particles. And it really is an interesting, powerful look. So just finally, let's have a look at how we can just slightly adjust this rig to get that more kind of realistic sand simulation that we saw. And actually, it's incredibly simple and uses exactly the same technique. So first of all, what we need to do is actually take away a lot of this animation that we've added for our nebula scene. We don't need our noise to be animating, because obviously we want the sand to kind of be static apart from the way in which it's being pushed against each other. So what we could do to get that set up is, let's do the display first, so it's looking a bit more like sand. And all we need to do here is go to our emitter, and instead of it being obviously this kind of nebula look, we want it to look a bit sand-like. So let's just go to our display tab, and instead of displaying dots, we're going to display spheres. Because we're displaying spheres, and obviously it's having to kind of generate a three-dimensional shape, let's just reduce the particle count. We don't need quite as many for this sand, so we'll go to the emission tab and we'll reduce that birth rate down from 35,000 to say, I don't know, let's say 20,000 per second. Okay, back to the display tab, and instead of this gradient, let's load a preset. And with sand, you want kind of lots of different colors really. So let's just bring in this flame. This is the default max on flame 1, so we'll double click that. That's looking good. So if we hit play now we're getting this sand look, but obviously we're getting this animation because of our animated modifiers, and we don't want that. So we can switch the turbulence off. We don't need that. In the scale, we don't need the shader field to be animated anymore. We kind of want that to be static. So let's go to that shader field. we'll go to the noise settings and let's switch off that animation speed from 1 to 0, and let's switch off that speed of the movement to 0. So now that's sorted out. Let's go back to the emitter, and we don't want these particles being killed off now. This is sand, so we don't want the sand just to disappear. So let's go to the emission tab and let's click back on full lifespan. Let's hit play. Alright, so now we're getting this type of look. But one of the problems here is with our particles are scaling down and up a little bit too aggressively, and look, we've got a bit of a hole in our simulation here, and we can avoid that by reducing that contrast that we put into our scale modifier. Do you remember we made the blacks blacker and the whites whiter? Let's just make it a bit more grey. So we'll go to the shader field, we'll go back into this noise, and if we come down here, you can see, look, we clipped the low and the high to give us more black and white contrast in this thumbnail. So let's take that low clip off, and now look, it's much more grey, and we'll just take most of that high clip off. So now we're not going to be going down to 0 with the scale of those particles. Yep, that's looking better. And we could even perhaps reduce the particle count a little bit more. Let's go to the emission tab, let's put this on, say 15,000. Have a look, and it's looking pretty cool. And if we come really in close here, you can really see these spheres pushing against each other, and because they're being coloured via their radius, we're getting these really interesting coloration parts that look like the trough of the sand as it's making its way along the spline. So that's looking pretty cool. Let's just try reducing the radius a bit. So if we put a little less variation and reduce that down to, say, 0.4, let's hit play. All right, that's looking nice. And because we've reduced that down now, we need to just slightly alter what we have here. Let's put 0.4 as the max in the coloration. This is in the display tab of the emitter. And let's have a look. So we should have a couple more lighter ones. Yep, that's looking good. Okay, and that is how we did it. So we can go from having this very interesting kind of nebula look to something that's looking a little bit more like a realistic simulation, simulating sand in this instance, by just changing the particle radius, taking some of the animation out of that sim, and adjusting the particle count and size.